This lesson is going to cover the last of our learning targets, learning target 5, for our second unit on quadratics. This learning target will talk about how to add, subtract, multiply, and divide complex numbers. In general, what we're asking to do are operations. Add, subtract, multiply, and divide are operations. As a little bit of review about what complex and imaginary numbers are, let's use the quadratic formula on this quadratic. In this quadratic, we have an a of positive 2, a b of negative 3, and a c of 4. So let's plug that into our quadratic formula. X is equal to negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. Start to simplify this, and we end up with a positive 3 plus or subtract the square root of 9 minus 2 times 4 is 8 times 4 is negative 32 all over 4. And so our x is going to be equal to 3 plus or minus the square root of negative 23 all over 4. And remember, when we have a negative underneath the square root sign, it's a number that we cannot square root. So we express this with an I instead of the negative. So our final answer is 3 plus or minus I square root 23 divided by 4. So we're talking about i's today. So I stands for imaginary number. It is equal to the square root of negative 1. An important fact to know is that if we were to square I, we would be doing essentially I times I, which is the same thing as square root negative 1 times square root negative 1. And when you are multiplying two square roots together, you of course end up with an answer of negative 1, the number that's inside of this. Another way to write this, instead of showing it to you guys this way, would be to show you that I squared is the same thing as saying square root negative 1 squared, and a square and a square root cancel each other out, leaving you with just a negative 1. So remember, I squared is equal to negative 1. I is equal to the square root of negative 1. In standard form, we always write the normal number first plus, and then we write the part with the I. Sometimes it's a number with an I, like a 2i or a 4i, but we always put it second and put the normal number first. Why do we need imaginary numbers? Because as we graph parabolas, we end up with parabolas like we see right here. A parabola that does not cross the x-axis. Since it does not cross the x-axis, at first you think, well, wait a minute, then how could it have roots? So instead of having real roots, which would cross the x-axis, this parabola has imaginary roots. That's why it's important to know how to deal with imaginary numbers, because we have parabolas that don't cross the x-axis. So let's learn how to add and subtract complex numbers. Another way of saying simplify in this problem is to say that you're going to add the complex numbers. It's actually quite simple. We just look for the like terms and we combine them according to what we see. Since this is all positive, there's no negative signs in front, we can drop those parentheses because no sign change. A positive with a positive still remains a positive 2, and a positive and a negative still remains a negative 3i. So dropping the parentheses is okay for addition. So my like terms in this problem would be 3 and 2, which makes 5. My other like terms in this problem would be a positive 5i and a negative 3i. Positive 5 minus 3 gives me a positive 2i. So this is my answer, 5 plus 2i. In the second problem, when we want to simplify by subtracting complex numbers, we need to deal with the fact that a negative sign does affect the stuff inside of the parentheses. A negative and a positive 4 does make a negative 4. A negative and a negative does make a positive 3. A negative and a positive makes a negative 5. And a negative and a positive, so it's kind of like distribution, makes a negative 2i. So sign changes do happen when you are subtracting. We have like terms of negative 4 and negative 5 giving me negative 9. And we also have like terms of positive 3i, negative 2i, leaving me with a positive 1i. You can put a 1 in front of the I or not. So my answer is negative 9 plus I, or 1i. Multiplying complex numbers is similar. To multiply a 5i and a negative 2i, we're going to want to multiply the coefficients, so 5 times 2. We end up with negative 10, and we have I times I, which makes I squared. Remember I talked about how I squared is the same thing as saying the square root of negative 1 squared, which does equal negative 1. So this is negative 10 times negative 1, which is a positive 10. So careful, make sure that you are multiplying negative 2 and 5 and I times I. In the second problem, we have a 2 in front of these parentheses. Let's multiply the 2 by distributing it into the 4 and the negative 3 before dealing with the second binomial. This gives me a 8 minus 6i. Keep the parentheses. Now we're going to want to make sure we FOIL. Some people like the FOIL and some people like to use the box. Either way, that you like to multiply two sets of binomials is fine. I like to use my arrows and use FOIL. So we have 8 times 7 and 8 times I. This gives me a 56 plus 8i. 8 times I is 8i. I have to do negative 6i times 7 and negative 6i times I, which gives me a negative 42i, and then also a negative 6i squared for I times I. We do have like terms right here in the center, so we're going to want to combine those. And also remember that this I squared is equal to negative 1. So the 56 will remain. 8i plus 42i will give me negative 34i. And a negative 6 times a positive 1 will give me a positive. So my final answer would be 56 minus 34i plus 6, and we combine the 56 and the 6 to make a 62 minus 34i. So a little more work to consider as we multiply two sets of complex numbers, but they're the skills that we used earlier in the quadratic unit as well. So what is a conjugate? Conjugate is an important part of complex numbers, and it's important to understand what a conjugate is in order to do division. A plus bi and a minus bi are called conjugates. Notice the only real difference between these two is this plus sign and this minus sign. The a and the b in general remain the same. So what happens when you multiply conjugates? Well, let's try that. 2 times 2 is 4. 2 times negative 5 is negative 10i. 5 times 2 is a positive 10i. And 5 times negative 5i is negative 25i squared. These two in the center make 0. Negative 10i plus 10i makes 0. So I have a 4. minus a 25. I squared, remember, is actually equal to negative 1. So my true work is actually 4 plus 25. My final answer being 29. So multiplying conjugates actually removes the I completely from our answer because of the fact that the two terms in the center make 0 and an I squared actually is a negative 1, leaving you with just a real answer, 29. And no imaginary numbers are a part of this answer. So conjugates get rid of imaginary numbers. So let's use that while dividing, or what is better called rationalizing complex numbers. So what we have in the first example is a complex number divided by a complex number. We want to rationalize it. It means that we don't want an I, we don't want any kind of square root sign, which is what an I really is, in the denominator. So the way to remove the I is to multiply this by a conjugate. So I'm going to take my 1 minus 5i and multiply it by 1 plus 5i. But what you do at the bottom of a fraction, you have to do to the top of the fraction also. So let's multiply both these sets out. On the top, I end up with a 2 times 1 is 2, 2 times 5 is 10i, 3 times 1 is 3i, and 3 times 5 gives me a 15i squared. 1 times 1 is 1. 1 times 5i is 5i. Negative 5i times 1 is negative 5i. And negative 5 times 5, positive 5i, gives me a negative 25i squared. So let's combine like terms. This makes 0, so that will no longer be in my answer. On the top, I also have 10i plus 3i, that's 13i. And remember that this part, the 15i, is actually a negative 15i because I squared is negative 1. And the negative 25i squared is actually a positive 25 because the I squared is a negative 1. So when we write our answer, let's do 2 minus 15 and get negative 13. 10i and 3i make 13i. And a 1 plus a 25 is a 26. So this would be my final answer with no more i's in the denominator at all. It has been rationalized. In the second example, we have a 4i on the bottom of this fraction in the denominator. To rationalize this, we don't need to think about a full conjugate. Okay, all we need to do is to turn this I into an actual number. To do that, let's give it another I. Let's multiply this by I, because then it's going to say 4i squared. And as we learned from up here, I squared will multiply with the number and change the sign. So let's do it on the top, but let's make sure that when we multiply by I on the top also, because we have to be equal with the numerator and the denominator, let's make sure that we put parentheses around this so that we can multiply the I to both pieces and not just the I. So I end up with I times 3 is 3i. I times I is negative I squared. And on the bottom, I have 4i times I, which is 4i squared. So in two cases, I end up with an I squared. So I have a 3i minus a negative 1. And I have a 4 times a negative 1. Remember, I'm doing this because I squared is equal to negative 1. So my final answer would be a negative is a positive 1. Let's put them in front because that's standard form. And then a positive 3i afterwards. And on the bottom I have a negative 4. There's nothing else I can do to this expression to simplify it anymore. The key to this is to do what you have to do to make an I go away in the denominator. If you have any questions, feel free to shoot me a question using our Remind account. And if you need to, ask me something immediately. Otherwise, you can write down your questions in the left side column of your notes and bring them into class. Don't forget to click forward, answer the questions, and hit the submit button.